All right, so we're integrating, right? Now looking at this, there are a couple ways to deal with this, right? So there's a couple possibilities. One possibility is that this could be u sub, right? But if it were u sub, it's not for the record, but what your brain should do is think, hey, if this were u sub, my u would be at x squared plus 3x plus 2. If the top is some multiple of 2x plus 3, then this could be u sub. But this doesn't align well with this at all, so it's not u sub, okay? If the top had been like a 4x plus 6, great, right? Or anything that is a multiple of this, that's great, but it's really not, okay? So if it's not u sub, then it's likely partial fractions, right? Because the denominator factors, right? The denominator factors into an x plus 2, x plus 1, right? It is likely partial fractions. So I'm going to do the partial fractions decomposition for this thing. I'm going to say that 5x plus 8 over an x squared plus 3x plus 2 is going to equal a over x plus 2 plus b over x plus 1. So when I get a common denominator, my numerators can be set equal. So the a was missing the x plus 1, and the b is missing the x plus 2. I'm going to use some clever substitution to knock out some terms. If I plug in -1, I get a -5 plus 8 on this side. The a term is knocked out entirely, and I get a b times 1, so it seems to me that b is 3, right? If I plug in x as -2, that's going to knock out the other term, right? So that'll be a -10 plus 8. On the other side, I get an a times a -1, and then that term is knocked out. So I seem to get a -2 is my negative a, so a must be 2. So I now have my b and my a, meaning that this thing, I'm going to do this without bounds for a sec, right? This thing without bounds is actually the integral of a 2 over x plus 2 plus a 3 over x plus 1, right? And each of those is technically u sub, but it's a pretty straightforward natural log, right? This is a 2 natural log of the absolute value of x plus 2 plus a 3 natural log of the absolute value of x plus 1 evaluated on whatever interval I'm given, right? So now, if we go back up and look at the bounds I was given, if I evaluate 2 natural log of x plus 2 plus 3 natural log of x plus 1, I could evaluate it from 0 to 1 right now if I want. That's a totally acceptable option. You'll notice that the answers only have a single, log, right? So it's also very likely that they might combine these and make it a little bit simpler. Up to you what you want to do. So if I plug in the way it is now, I'm going to get 2 natural log of 3, right, plus 3 natural log of 2, right? That's what would happen here. Minus, and then if I plug in the bottom bounds, I'm going to get a 2 natural log of 2 plus a 3 natural log of 1. Well, the natural log of 1 is a 0, so that's great. So it seems that what I'm going to get is 2 natural log of 3 plus 3 natural log of 2 minus 2 natural log of 2. Well, these are like terms, so I get 2 natural log of 3 plus a natural log of 2, right? Because 3 of them minus 2 of them would be 1 of them, right? If I move this guy up, I get that this is a natural log of 3 squared plus a natural log of 2. So that's a natural log of 9 plus a natural log of 2. And log properties state that I can combine these into a single logarithm with multiplication, so I get the natural log of 18, which is one of the answers that's up there, presumably. And it's C, and that's my answer.